Okay, so this is lesson 8 for group 1, and this is going to do with percent error problems. This is a little bit different, so do try to pay attention. If you don't get anything, obviously watch the video a couple times, but it's actually should be a shorter lesson, so let's keep our fingers crossed on that one. Okay, so we start out, we get a bunch of measurements from Taylor, Connor, and Jordan, whoever they are, and they want to know, find the absolute error for the following problems. So basically, they're asking how much is these students' measurements, Taylor, Connor, and Jordan, from the actual measurement. And in order to do that, you have to know that the actual measurement is 15 inches. Okay, so with that, you should pretty quickly be able to get the answers for Taylor, Connor, and Jordan's second measurement. So do pay attention to that. So what you're trying to figure out is how far are they off in terms of inches. So Taylor's measurement was 15 and 2/8, and the actual measurement was 15. So find out what the error is for each person. Connor's measurement was 4/8, and Jordan's second measurement was 14 and 6/8. So find out how much they were off with their measurements. Okay, so let's see how you did. The first one was 15 and 2/8, and the actual measurement was 15. That means that Taylor was off by 2/8 of an inch, or if you wanted to simplify it, you could also have it as a quarter, 1/4 of an inch. Okay, he was a 2/8 of an inch too much. Connor, on his first measurement, is 15 and 4/8, which means he was 4/8 too much or too long. And you could also simplify that to 1/2 an inch. So he was off by half. And then for Jordan's second measurement, he measured it, or she measured it at 14 and 6/8, which means he or she was also off by 2/8 of an inch. So Taylor and Jordan were both off by the exact same amount, except Taylor was 2/8 too much, 2/8 over because it was 15, and Jordan was 2/8 too short. Okay, so they basically have the exact same absolute error. How far are they from the correct answer? So Taylor and Jordan are off by 1/4 of an inch, and Connor's was the worst measurement. He was off by 1/2 an inch. Okay, so that leads us to what we're going to be working on is basically figuring out a percentage of the error that they made. So when you do these problems, what you need is you have to have what the guess was or the estimate. And then you subtract the actual. And this will make more sense as we go about. So we subtract the actual, which is what we did up here, or what you should have done. We had 15, and we subtracted that away from 15 and 2/8, and we found out that the error was 2/8. And then you are going to divide that by what the actual was. So we have our guess or estimate, what we thought it was going to be. We subtract the actual, which again, it's not going to matter because when you subtract, you're going to change that into plus negative anyway. So it shouldn't really matter which number you use in that case, but it will matter which number you divide by. So you have your guess or your estimate. You subtract the actual amount or the correct amount. So then you'll get basically what we got up here. This was the amount of the error, 1/4 of an inch, 1/2 of an inch, or 1/4 of an inch. And then you divide it by the actual amount, actual or correct amount. Like I said, you'll see this as we do it. So it says find the percent error for Taylor's measurement number 1. Well, we already know that he was off by 1/4 of an inch. So we don't have to do the subtracting part because we already did that in the first part. But we do have to do the dividing part. And we have to divide by what the actual answer was. What is the actual correct amount? And in this case, so this is problem A, by the way, we are going to divide this by 15. Why is it 15? Because that's what it actually was. So for this, we're going to divide 15 into 1/4. Pull out your old dividing by fractions rule. So 1/4 divided by 15 over 1. Okay, and then flip it on over. Get 1 over 60, but we want a percentage, so that's not going to be good enough. We have to divide this out. So 60, we divide it into 1, add a decimal because you know you're going to need it. Okay, so 60 won't divide into 1, 60 won't divide into 10, 60 will divide into 100 one time, subtract 60, and we get 40. We could probably end it at this point because we have our percentage. We have 0.01 and we have 40 over 60, which you could simplify. So we could do that, 40 over 60. Common denominator for 40 and 60 would be 20. So I divide this by 20. You would get 2. And divide this by 20, you would get 3. So you get, basically for this, you would have 1 2/3%. Okay, so fairly accurate. I was off by less than 2%. Okay, so Connor is very similar, except his error was different. He's off by 1/2 inch. So based on what we did here, go ahead and do Connor's margin of error and then continue the video. Okay, so just remember when we're dividing by 15, not by 1/2. So 15 is the number that's going to go second. It's also the number that's going to be flipped over. If you did this the wrong way, you're going to end up with 60, and that doesn't even make sense. 60 would be like 6,000%, and that doesn't even make sense. The correct answer, though, is 3 1/3%. You divide by 15, which means 1/2 times 1 over 15 equals 1 over 30. Do the division over here, 30 into 1. Just remember, once you get past that decimal place, you have to put in those zeros there. If you got just 3, that's because you're not filling in your zeros. Once you get past the decimal point, every time you go past another place value, you have to put a 0 at the top for your answer. As you can see, the answer works out pretty easily. We have 10 over 30, which I can simplify by dividing by 10 and end up with 1/3. So that's where 3 1/3%. What does that mean? That means he was off by his answer. In terms of measurement, he was wrong by 3 1/3%, or basically doubly wrong, more wrong, I guess, than Taylor's answer, or less accurate. We won't bother with C because, as we said before, Jordan's measurement is exactly the same in terms of margin of error as Taylor's measurement. It'll end up exactly the same. One was too much and one was too little, but the margin of error will still be 1 2/3%. So no reason I'm doing that exact same problem. And what's the purpose of finding percentage error? This basically tells you how your answer compares to the actual answer in terms, usually like when you're estimating or doing a measurement. Okay, so let's do this. So now this one, you're going to have an extra step because you will not have done the subtraction yet. But it's really easy. We'll walk through kind of the first one as we go. So it says a real estate agent expected 18 people to show up. So that was what was expected. 18 show up, but 25 attended. So we're trying to find what's the margin of error. So once again, we're going to take the 18 people, which was how many he thought, or she could be, she also was going to show up. And we're going to subtract 25. It doesn't matter, again, if it's positive or negative, because it's going to be a positive percentage anyway. So we start with 18, and we're going to subtract how many people actually showed up. What was the actual answer? In this case, it was 25. And then when we're done with this, if we were going to do this in one equation, we would then put this over 25, and this would have to be in parentheses because that has to be done first. So basically, you subtract these from each other, or you change this into 18 plus negative 25, if you want to do it that way. But you should get 7, okay, or negative 7, doesn't matter. So 7 is what is the absolute value? What percentage is that off? So we take this number, so all we did is subtract these two, what we thought was going to happen, or we thought we were going to get, and the actual. In other words, actually 25. Now we're going to divide this by what actually happened. So in this case, we have 7 divided by 25. Okay, go ahead and do that really quick and continue when you're ready. Okay, so as I said, so we have negative 7, and we divide it by 25. Why 25? Because that is the actual amount that showed up. That is the correct amount. So I went ahead and did that over here. Works out pretty quickly. We get 0.28, which is 28%. So he was off by 28% in terms of his estimate. Okay, number 2. Same idea, but this time we'll let you do this one all the way to the end on your own. So it says, in science class, Mrs. Moore's students were directed to weigh a 300-gram mass on a balance scale. Tina weighed the object and reported 328 grams. So what is the margin of error for Tina? Okay, go ahead and work that out, and when you're ready, resume the video. Okay, so we have 328, which was the guess, the incorrect amount, and we subtract what the actual amount is. In this case, it was 300. That was what the actual weight of the item is. So that gets us to 28. So that's the amount of the error. She was off by 28 grams, but that's not the percentage. And in order to do that, we have to divide 28 by 300. Because 300, once again, is the actual amount. We always divide by what is the correct amount. Okay, and that works out pretty quickly. Add a decimal. Once again, make sure you're adding your zeros. So 300 won't divide into 2. It won't divide into 28. It also won't divide into 280. So that's the first zero you have to put. You can put the zeros on the left of the decimal place, but once you get to the right, you have to put them in. You end up with a remainder of 100, and once you get 2 places past the decimal, you can just stop and use it as a fraction. And so that means the answer is 9 1/3%. Okay, so still fairly decently off there. All right, so last one of these. Then we have one more type of problem, then we are finished for the day. So like I said, a shorter lesson. Darwin's coach recorded that he had bowled 250 points out of 300 in a bowling tournament. However, the official scoreboard showed that Darwin actually bowled 225. So there's no question here, but obviously they want you to find the percentage of error. So go ahead, work this one out, and when you're done, continue. Okay, so the guess or the incorrect answer is the 250. It won't really matter. Even if you put 225 and subtracted 250 from it, you'll end up with a negative 25, but it doesn't matter. It will still work out for these problems, at least now anyway. So go ahead and subtract that. You should have got 25, okay? But that's just the amount of the error. What is the percentage? We got to divide that by the correct amount, and that would mean dividing 25 by 225, because the 225 is his actual score. So we go ahead and divide that. We get 11 and 25 repeating decimal, 25 over 225, which you can then simplify to 1/9. If you didn't do that, you still would have been pretty fine as far as I'm concerned if you got to that point. Okay, so far, hopefully nothing too difficult. This next one is a little bit different because it's going to be talking about dealing with an estimate. So if you just pay attention a little bit and we'll be done, and that's pretty much it. Okay, so it's the same thing, except this time they don't give you any actual amount. So it says the attendance at a musical event was counted several times. All counts were between 573 and 589. If the actual attendance number is between 573 and 589 inclusive, what is the most the percent error could be? Explain your answer. Okay, so we have basically a range. We know that it's somewhere between 573 and 589. So the point of this, okay, so the first part is pretty simple, is we need to find what is the greatest amount of error it could be. So we know we have two numbers, 573, 589. What do you suppose we're going to do with those numbers to find the amount of the error? The greatest amount of error it could be is we're going to subtract those two. So 589 and subtract 573. So go ahead and let's do that over here. Okay, so 16, that was pretty quick. All right, so this is the amount. So it could be off as much as 16, but that's not the percentage. We want to know what is the greatest percent of error it could be. So what are we going to divide by? Because we don't know what the actual number is. Now, when you think about this, we have two numbers here. So we're going to divide this number, 16, by one of these two numbers, obviously. Which one of those, if we divide it, is going to give us the greatest number? So we have 573 and 589. Just give you an example. So let's say if we add the number 10, I'll do it twice. If we divide the 10 by 2, if I divide 10 by 5, so I'm dividing it by 2, I get the answer of 5, so this is my answer. If I divide the answer by 5, I get 2, and that's my answer. So I divided by two numbers. I've divided by a small number, or a smaller number, and a larger number. Which one gave me the greater answer? Right. Hopefully you said the smaller number. So if I divide by the smaller number, it's going to give me the larger number. And that's something to watch. If they want the greatest percent, well, the smallest percent of error would be 0. But what is the greatest percent of error they could be? Meaning they could be count 573 and it could be off by 16. So what we're going to do is take this number, so we just took the two numbers and subtracted them, and we divide by the smaller number. The smaller number is going to give us the greatest percentage. So go ahead and do that, and that's actually the last part. So go ahead and do that and get your answer. Okay, so as we said, we took 16 and divided it by 573 because that's the lower of the two numbers, and you should have got basically 2%. So that would be the greatest margin of error is 2%. Okay? All right, let's take a look at your problem set, and we'll be all set for today. This is basically doing these types of problems. So you take the two numbers, always subtract them from each other. So what was, and you divide by what is the correct amount. Okay? you can go ahead and skip 4. Don't worry about the geometry problem right now. And 7. So do 1 through 11, but you do not have to do 4 and 7 on your assignment. Okay. Although if you want to do it for extra credit, I'll go ahead and give that to you. But you do need to show me your work for that. So when you find the area and that, make sure you include your work with that. All right. If you have any questions, post it with this video or on the classroom, and I'll get back with it as soon as I can. Okay.